that this evening in an class that I host with one of the math teachers here, Ms. Mota, we are having a science and math tutoring session. So I made a post about it in the stream yesterday. There it is. So tonight from 6:35 to 8, we'll be doing a science and math tutoring time where anybody who has questions about anything going on in their science or math classes is free to come and join us. That includes you guys as well. If you have any questions for me, either about this class or about the STAR test, if you're taking the biology STAR test coming up, feel free to come along and ask. Or if you have any questions about any of your math classes, you can take them to Ms. Mota and she can help you answer them. So again, that is tonight from 6:30 to 8. We'll have it open during that entire time. So feel free to hop in and join if you have any questions about anything going on with science or math classes or testing this term. Like I said, make sure you don't forget about the midterm due at the end of the day tomorrow. And so the last thing that we're gonna cover this week and the final set of questions on the midterm, I think there's 1 or 2 questions on this, has to do with the different way that we can mix and combine atoms together. So we'll be looking at the different ways that we can classify matter. So again, matter, just our fancy science word for like stuff, things that are out there in the universe. And so today we're going to be talking about how can we put matter into different categories? How can we look at it and the particles that make it up and figure out kind of which category it goes into? So the first thing that I'm going to do, I'm going to show you a big flow chart of all the different categories. Don't worry about them right off the bat. A lot of them will probably look new to you and not make a ton of sense. But we're going to go through each one of those pieces one by one, talk about what it is, give some good examples to make sure that everybody feels comfortable with it. So here is our big overall flow chart. In general, matter can be put into 2 kind of broad categories. Either it is a mixture of lots of different types of substances and particles, or it is a pure substance that is made up of just one type of particle. If it's a mixture, it could be a homogeneous mixture or a heterogeneous mixture, and we'll talk about what those are a little bit later on. And if it's a pure substance, it could be a compound made up of different atoms that are bonded together. So that's what we were talking about on Tuesday. When atoms go through ionic bonding or covalent bonding, they become a new substance, and we call that new substance a compound. Or maybe we just have one single type of atom, also known as an element. So one single type of element present would also give us a pure substance. So we're going to talk about what each one of these things mean and what it looks like one by one. And we're going to start off with our pure substances over here. So a pure substance is when you only have one type of particle present. So when you only have a 100% pure set of one type of particle, that is when you have a pure substance. So nothing else is mixed in. There's not lots of different types of things all mixed together. It's just one type of particle. So we can divide our pure substances into one of 2 groups. We could have a pure substance made up entirely of one single type of atom called an element. Or we could have a pure substance that is made up of different atoms that are bonded together called a compound. So like here, for example, is a compound of 3 atoms. there's two different atoms, this black particle and this white particle, and they're all bonded together. So either because of an ionic bond or a covalent bond, all three of these guys are stuck to each other this way. And each one of the particles in our little picture here looks the exact same, right? They're all like twins of each other. So all of them are one black and two white particles that are bonded together. So we got this guy and this guy and this guy, and they're all the same. And because these guys are all the same, that is what makes them a pure substance. So in order to be pure, all the particles have to be the same. We can still have different atoms. Like I said, these guys are made out of different atoms. We have black and white together. But because they're bonded into one overall particle, and every particle in here is the same, then we have a pure substance. So in order for something to be a pure substance, every single piece of it has to look the exact same, whether those are all single atoms or whether those are the same compound over and over and over again. So an element, a pure element, is when your matter is composed of entirely identical atoms. Every single atom in this substance looks the exact same and is the exact same as all the other atoms. So like this vase right here is a copper vase. So if you could look down at like the tiny microscopic level, every single atom in this vase is copper. There's not like any oxygen mixed in or carbon mixed in or iron or silver mixed in. It's all 100% totally pure copper. Cu atoms as far as the eye can see. Only copper atoms in this vase. Same thing with this gold bar over here. So gold, which has a chemical symbol of Au, it's one of those weird ones. Every single atom in these gold bars is a gold atom. Again, there's no like nickel or iron or aluminum mixed in. It's 100% totally pure gold. So that's what makes it just a single element. There's no other different types of atoms in there. Every single atom looks exactly the same as all the other atoms. So because all of the particles are the same, it's a pure substance. And because it's all the exact same atom, that makes it a pure element. So next up, we have what happens when you don't have all the exact same atom, but what happens when you have different atoms that are bonded together? They've made an ionic bond or a covalent bond with each other. In that case, we have a compound. So a compound is what you get when you have two or more different elements that are bonded together. So different is the key word right here. If there's different atoms in there, then we no longer have a pure element, we have a compound. So either they're covalently bonded or they're ionically bonded, but somehow these different atoms, these different elements are bonded together. They're stuck with each other. So like we talked about on Tuesday, when you bond atoms together, you create a new substance, a different substance than what was there before. And so the properties, those chemical and physical properties, are going to be different. They're going to be new. Like in the example of salt. So you may remember sodium and chlorine from Tuesday. That's the example that we used for our ionic bond. Sodium has that 1 electron on his third shell. Chlorine has 7 electrons on the third shell. So chlorine takes that electron from sodium. This guy becomes positive. This guy becomes negative. The positive and the negative attract to each other, and sodium turns into a compound called sodium chloride. So sodium and chlorine are ionically bonded together, and they make a new compound, which we know as table salt. Table salt is very different from pure sodium or pure chlorine. 100% pure sodium is actually an extremely unstable reactive element. It'll explode if it comes into contact with water or moisture in the air. And chlorine, when you have pure chlorine, it's usually a gas, and it is a very toxic gas to humans. It's a potentially deadly gas. So you take this explosive thing and this deadly gas, but when you mix them together and they bond and form a compound, they make salt, the stuff that we put on our food to give it that little extra kick of saltiness. So compound, because we have these two different atoms that are bonded together. Other common compounds that you may know about that we talked about a little bit possibly on Tuesday include things like water. So in water, you have two hydrogens and an oxygen. I believe these guys are usually making a covalent bond. So these guys are different atoms, but they're bonded to each other. The two hydrogens are both bonded to the oxygen atom. So if this was only totally 100% pure water in here, then we could say that this is a pure substance made up of a single compound of water. There's different atoms, there's different elements, right? There's hydrogen and oxygen, but they're bonded together, and every single particle in here is a water particle. Every single one is the same as the other, so it makes it a pure substance. Carbon dioxide is another common compound. It's one that we breathe out every time you exhale. As I'm talking right now, there's carbon dioxide coming out of my mouth and through the mask here. That is CO2 is what carbon dioxide is represented as. Two oxygen and one carbon atom that are bonded together. So again, different atoms, but you bond them together and they become one single compound. If we look for a little bit larger compounds, one that maybe isn't part of your everyday life, but maybe more like every week or every month life, we have ethanol, which is most notable for us because ethanol is the alcohol that we consume in things like beer and wine and spirits. So in chemistry, there's lots of different alcohols that are out there, but ethanol is the one that we normally refer to as alcohol, as being the thing that we drink. Ethanol is a little bit bigger than these guys. It's two carbons, 5 hydrogens, and an oxygen-hydrogen group on the very end. But all of these are still bonded to each other. They're still making one large structure. So ethanol itself is still a compound. So if you had 100% pure ethanol, like something you use to sterilize or clean something, that is made up entirely of C2H5OH molecules. Those are the only compounds that are in there. No other atoms or compounds are present. And that is what would make it a pure substance. So we have our elements, our atoms, that are on their own, making up something entirely of just that single type of atom. And we have our compounds, two or more different atoms that are bonded together. But as long as that's the only compound that's in your substance, you can still call it a pure substance, because that's the only type of molecule or only type of particle that is present in your substance. All right. Anybody have any questions so far? Anything about elements or compounds you're still a little bit confused on? All right. Sounds like we're all feeling okay with this stuff so far. So we will move on to our next thing, which is, this is all great for when we've got pure substances that we're dealing with. But what about if we don't just have one element or one compound? What if we have lots of different elements and compounds all combined together, all swirling around, combined in together? Well, in that case, we don't have a pure substance anymore. Instead, we call it a mixture. So a mixture is when you have a combination of two or more pure substances. So you end up with multiple different particles that are all mixed together. Some of them might be pure elements, some of them might be pure compounds, but you mix them together and they're no longer pure. You have lots of different particles all together. So now it's not a pure substance anymore. It is a mixture. So for example, in our picture down here, we have lots of different particles that are in here, right? I count at least 3. There's this one black atom, there's these 2 white atoms together, and there are these black and white particles that are combined together. So we've got this guy, this guy, this guy. That's one type of particle. We have this guy and this guy and this guy. That's 2 types of particles. And we have this guy and this guy and this guy. That's 3 types of particles. So now I'm going to give you guys a super simple little pop quiz here. So feel free to answer either out loud or in the chat. But tell me if it is an element or a compound. So what about this guy right here, this single black atom? Would this be considered an element or a compound? So there's this guy over here, there's this guy. Are these guys elements or compounds?
I didn't hear the second half of your question.
So this single black atom right here, there's 3 of them in this mixture. Would these be considered elements or compounds?
Compounds?
Not quite. So this would be an element, right? If we're just looking at these 3 black atoms, they're not connected to any other type of atom, right? It's just the black one on its own. So this guy would be an element right here. What about these guys right here? We have this one black atom and 2 white atoms that are bonded together. We've got this one and this one and this one. So would this guy be a compound or an element?
Compound.
Yeah, compound, exactly. We have different atoms that are bonded together. So we have the 2 white atoms that are bonded to the black atom. So when we have different atoms bonded together, we have a compound. So those ones are a little bit straightforward. But what about this guy right here? So it's 2 white atoms that are bonded together. So would this guy be classified as an element or a compound?
Compound.
Aha. So you might think that it's a compound because it's 2 atoms that are bonded together. But in order for it to be a compound, they have to be different atoms. And in this case, these guys are the same. It's 2 white atoms that are bonded together. So these guys would still be classified as an element. So you see this happen a lot in nature, actually. There are certain atoms that don't really like to be on their own. They like to be paired up, like with one of their twins, essentially. So like hydrogen, you almost always see it in nature as H2 gas, two hydrogens together. And oxygen, you probably heard of O2 before when people talk about like breathing. Oxygen also does not like to be on its own. It likes to be connected to another oxygen atom. But since it's both the same atom, since they're both oxygens, then it's still classified as an element. In order to be a compound, it has to be different atoms. So in our mixture here, we have two elements in one compound. We have the single black atom element. We have the double white atom element. And we have the black and white compound. So again, element, when you have a single type of atom on its own. Compound is when you have different atoms that are bonded together. So when you take all of those different types of particles and mix them all up, you get a mixture. So we can classify our mixtures into kind of two different overall groups based on how evenly the different particles in them are spread apart. So our first type of mixture is called a homogeneous mixture. So in science and in Latin, homo usually refers to the same or similar. And so homogeneous mixtures are when you have equal and even distribution of your different particles, of your components. Everything in your mixture is totally evenly spread out from all the other particles. So no matter where in the mixture you go, you have the same mix of the same types of particles. Everything is equally and evenly mixed around. So for example, in something like eye drops, like saline solution here, it's a mixture of eye medicine and salt and water. And whenever you put these in your eye, every single drop that comes out of this eyedropper should be the exact same, right? You don't want it to where the first couple drops all have super concentrated medicine in them, and then the last couple drops are basically just water. That's no good. That defeats the purpose. You want every drop to be the same. So no matter where you are in your bottle, at the front, at the middle, at the end, it all has the same combination of salt, water, and medicine. All of the different particles are evenly mixed together, evenly distributed throughout the entire bottle. Some other kind of everyday good examples of homogeneous mixtures include things like mouthwash. So when you mix the stuff around in your mouth, it has the antiseptic, it has water, and some like flavoring chemicals. Each one of those each one should be the same taste and the same feel, because each swig that you take should have the same combination of medicine and water and flavoring. It's all evenly and equally distributed throughout the entire bottle. So every single sip, every single capful should be the same. Same thing with like vinegar, like classic white vinegar. Vinegar is a mixture of a particle called acetic acid and water. So two different compounds that mix together to make this mixture. And every single capful of vinegar should have the same combination of acid and water, right? You don't want it to be where your first couple of capfuls are like super, super strong, and then when you start to get to the bottom, it's really watery. That's no good. So the acetic acid and the water are completely evenly mixed throughout the whole bottle. That's what makes it homogeneous. Same thing with like coffee. As long as you're doing like a drip coffee or a pour over coffee kind of thing, where all the grounds are held up by the filter at the top, and then the hot water comes through, and in the pot, you end up with an even combination of water and caffeine and flavors that came in from the coffee beans, right? So every sip of coffee, assuming you're drinking like black coffee and you haven't mixed other stuff in, but every sip of coffee should taste the same. All of the caffeine and coffee flavor and water should be evenly mixed together. No matter if it's your first cup or your third cup, it should taste the same. There should be the same combination of mixes. In some cases, if you have some sort of coffee devices, it is not homogeneous. So like, I don't know if you guys have ever used a French press machine before. It's a simple little coffee maker. My wife likes to use them sometimes. She's super into like different ways to make coffee. And essentially you mix the grounds and the boiling water in this little tube together. And then there's a plunger that pushes all of the grounds down to the bottom. And so just the water is on top that you can pour off into your cup. But before you pour it out, you no longer have a homogeneous mixture, right? You have all of these coffee grounds at the bottom of your cup and all of the liquid is sitting at the top. So you have different amounts of different types of material in different areas of your mixture. That is not homogeneous. In order to be homogeneous, it has to be all the same, all evenly mixed together. One of my personal favorite examples is smooth peanut butter. And so I'm personally a big peanut butter fan. I still love making PB&J sandwiches for lunch every now and then. And so smooth peanut butter is the normal types you buy at the grocery store are a mixture of ground up peanuts and a little bit of oil and a little bit of sugar. And so in your normal can of like Jif or Skippy peanut butter, all of those are totally evenly mixed together, right? Every spoonful of peanut butter should taste the same, should have the same particles in it, have the same combination of ingredients. It's all going to taste the same and be the same from top to bottom, right? Now, sometimes you can buy like the fancy, like organic, natural peanut butter, or there's a kind that you can make yourself from like the powder. And that one, a lot of the times, what will happen is that the oil, if you let the peanut butter sit for a little bit, the oil will kind of rise and sit on top. So that when you open it again, you have to mix it all up again to get the oil resituated. That is not a homogeneous mixture, right? If your liquid oil is sitting on top and then all of the peanut stuff is underneath, that's not totally evenly and equally mixed around. You have a really heavy oil area and then a really heavy peanut area. So that would not be homogeneous. Also, if you had, say, crunchy peanut butter instead of smooth peanut butter, I normally go for the smooth peanut butter, but occasionally to mix things up a little bit, I'll have a little bit of crunchy peanut butter. Obviously, crunchy has those big chunks of peanut in it. And in crunchy peanut butter, every scoop might not be the exact same, right? Some areas of the jar might have peanuts that are really thickly clustered together, and some areas might have the peanuts that are kind of spread out from each other, and there's less of them. So in crunchy peanut butter, it would no longer be 100% fully, evenly, and equally mixed. So that would not be homogeneous. Only smooth peanut butter is a homogeneous mixture, where every spoonful is the same, every piece of peanut butter from the jar is the same, because all of the peanut and oil and sugar are all totally evenly and equally mixed together. So I've given you some examples already of things that are not homogeneous mixtures, where we have different amounts of particles in different areas. And of course, in science, there is a term for that. So the opposite of a homogeneous mixture is called a heterogeneous mixture. So hetero in science and in Latin means like different or opposite or not the same. So in a heterogeneous mixture, we have an uneven distribution of components. Some areas might have particles that are closer together. Some areas may have more of one type than another type. Some areas might have them where they're really spread out and far apart. So heterogeneous is uneven, unequal. You don't have the same mix of particles throughout your entire matter. So like this granite here, if you were to really zoom in and look at all the little different areas, you'd see that no two sections of this granite are exactly alike, right? Even just looking at it right now, I can see there's some areas that have a lot more like of the little black specks. And then over here, there's more of the white and gray specks. And even those specks come from the different minerals in the granite being either more or less present in different areas. So we don't have a totally even and equal distribution of all the minerals in our granite. There's these little clumps all spread out of high types of one type of mineral, but less of another. And that's what gives you all this kind of dotted effect on the granite. Other kind of everyday heterogeneous mixtures would be something like this salad right here, right? Unlike the peanut butter example from earlier, every scoop of this salad, every forkful, is not going to be the exact same, right? Sometimes you might get more of the raspberry, and I think this is pineapple maybe, or mango, something like that. But sometimes you might get some more of the almond and the blueberry, or sometimes you might just get a full scoop of spinach, or some areas might have really thick salad dressing, and some areas have thin salad dressing. That is a heterogeneous mixture. Not all the pieces are the same everywhere you go. There's different amounts of different types of particles in different areas. Same thing going on the food examples again with this zesty Italian dressing, right? So the dressing itself is a mixture of oil and water, but then it's got all of these big chunky particles in it, right? I think it's probably like onions and peppers and garlic maybe. So these are not all spread out the same, right? There's some more of the red pepper particles over here than there is over here. And there's a whole lot more particles that are kind of settled on the bottom down here versus at the top. So this is a very heterogeneous mixture. We don't have a fully evenly mixed, everything evenly mixed together type of mixture. Every single capful, every single pour of this salad dressing is going to have a little bit different combination of dressing and chunks of stuff. Same thing, even if you go outside right now and reach down and pull up a scoop of dirt, that dirt is going to be a whole bunch of different things mixed together. So you might find some sticks in one area, but one area is like a lot more rocky. And this top dirt might be really packed together soil, but then this middle level has a whole bunch of clay in it, which is what makes it kind of that yellowy color. And then this bottom area is super silty and sandy. So this is a very heterogeneous mixture. You can even see there's literal layers between the different types of particles. So these guys are completely separated from one another, and they're all mixed in with all sorts of different amounts of rocks and insects and sticks and stuff, all in different areas. So heterogeneous mixtures are all about being uneven and unequal. You do not have the same combination of particles everywhere that you go. No matter where you look, you're going to find something a little bit different than where you were looking before. That's what a heterogeneous mixture is. All right, so our mixtures are whenever we just have different types of particles together. It could be different elements, it could be different compounds, it could be different elements and compounds all together. Homogeneous mixtures, everything is the same, everything is equal, no matter where you go in the mixture, it all looks the exact same. Heterogeneous mixtures are the opposite. Different amounts of particles in different places. It's not the same, it's not even, it's not equal. Those are kind of our two major categories of mixtures that we can have. All right, so does anybody have any questions about the mixtures so far? Homogeneous versus heterogeneous mixtures. Anything you're still a little confused about? All right. Sounds like there's no major questions up till now. So if we look at our big matter flow chart again. Separated by physical means is just a fancy way of saying, do we have different particles that we can move away from each other if we wanted? So if we do have lots of different particles, we have a mixture, right? Different things, different compounds and elements all mixed together. If we don't, if all the particles in there are the same and we can't separate them, we have a pure substance. Every single particle looks the same as all the other particles. In our mixture, uniform composition just means it's all the same. So if it is that case, then we have a homogeneous mixture. Everything, all of our particles are evenly and equally distributed. There's the same amount in the same areas of the mixture. Everything is the same throughout the entire mixture. If that's not the case, if we have different particles clumping or spreading out in different areas, then we have a heterogeneous mixture. On the other hand, if we don't have a mixture, if we only have one type of particle with our pure substance, then it's either made out of different atoms that we could chemically split apart if we had to, in which case it is a compound. So a compound is just different atoms that are bonded together. So two or more different atoms bonded together, like water is H2O, two hydrogens and an oxygen. Carbon dioxide, CO2, two oxygens and a carbon. Different atoms bonded together gives us a compound. And if that is the only compound in our substance, it is a pure substance. Finally, if there's only one single type of element that is present, no other atoms, no other different types of atoms or elements, only the one, then we have a pure element. No other atoms are getting in there and either mixing it up or bonding with the element. It's just that one element, like pure gold or pure copper, something like that. So that, when we're looking at matter, those are sort of the different categories that we can put it into. Is it a mixture that's multiple compounds and elements mixed together? Or is it a pure substance that's just one element or just one compound? And then if it's a mixture, is it all evenly and equally spread out? Or is it not evenly distributed? Are there different clumps, different pockets in different areas? That is our kind of overall view of the different ways that we can categorize matter based on kind of what it is made out of. All right, so if we take a look at what your homework for today and tomorrow deal with, I tried to make them short and easy since you also have the midterm that you guys are working on. So I think today's is like 2 questions and tomorrow's is 3 questions. So for today's homework, it starts off with kind of a little bit of an overview of some of the stuff that we were just talking about in case you need a little bit of a refresher. So we have our individual atoms that are our elements. They can be single atoms on their own or 2 of the same atom that are together. These are both elements right here. But if we have different atoms that are bonded to each other, then we have compounds. If we only have one type of element or we only have one type of compound in our substance, then we have a pure substance. But if we have different atoms and compounds mixed together, we have a mixture. We can have homogeneous mixtures where no matter where you go, you get about the same combination, the same mixture of atoms and elements. So in this case, our white atoms and our black atoms and our 2 white, 1 black compound are all here in about the same amount, spread out in about the same way. So that makes it a homogeneous mixture. Whereas in our picture over here, all of the white elements are clumped together on the right, and all the black elements are clumped on the left, and all of the compounds are sitting there in the middle. So this is a very heterogeneous mixture. There's different makeups of particles depending on where you go. It's not all the same throughout the whole thing. So your job for today and tomorrow, again, I think today has 2 substances. Yeah. And tomorrow has 3 substances. So for each one of these substances, I want you to tell me 2 things. What type of substance is it? Is it a pure substance, a heterogeneous mixture, or a homogeneous mixture? And what type of particles are present? So are there only elements that are there? Are there only compounds that are there? Or are elements and compounds both present, both making up that mixture? So for today, I want you to tell me about that for substance 1 right here, and then substance 2 right here. And then on Friday's homework, it'll basically be the exact same thing, but with 3 different substances. So 3 new substances, but you're still going to tell me what type of substance, a pure substance or one of the mixtures, and what particles are there, compounds, elements, or both. So those are your daily assignments for today and for tomorrow. Again, please make sure that you log on Friday and do your Friday assignments, earn that attendance for Friday. But then again, there is no homework on Monday. You guys have Monday off. So you won't see another assignment until we come back together as a class on next Tuesday. So on Monday, May 3rd, no day classes, no IPC homework or daily assignment or attendance. But make sure that you do that Friday assignment and make sure that you finish up that midterm by the end of the day on Friday. All right, does anybody have any questions about anything that we've talked about today so far? Anything about the notes or your Thursday and Friday homework assignments? All right, so again, don't forget there is going to be some science and math tutoring going on tonight at 6:30. You can find the link for that under our homepage. If you scroll down a couple spaces right here under Science Tutoring Thursday. So please feel free to drop in anytime between 6:35 and 8 if you want to ask some questions about this class, any of your other science or math classes, or anything related to the biology or algebra STAR tests.